All right. We are gonna do some boards go up, please. But it will be sorry, I'm getting distracted. It is spherical coordinates. We're gonna do three problems. They get kind of progressively more complicated as we move along. So here I tell you the function that I want you to integrate. F of x comma y comma z is just y, so it's just one variable. And I want you to integrate that over the region x squared plus y squared plus z squared is less than or equal to 1. So that is the unit sphere. But notice so I want the unit sphere, but I want x, y, and z to all be positive. So go ahead, pause this and try it. I'll do incremental things where I like show you what the bounds are, and then I'll let you go again. But anyway, pause it, try it, see if you can get all the way to the end. I got boom, pi over 16. Let me show you what my bounds were, and maybe that'll help you if you had trouble with the bounds. Well, here I'll go through what I what I worked out here. So the unit sphere is a radius of 1. That's what tells me that rho is going to go from 0 to 1 right here in my bounds. And I'm working in the first octant, right? So I guess actually that is the 0 part. The 0 is like all of the first octant, and it ends at 1. Um, then if you think about, I've got like a little picture right here. If we were in the first octant, right, theta would spread from 0 out to there, out to pi over 2. And then phi would go from 0, which is like straight up the z-axis, down to the xy plane. And that would get the whole first octant, right? So that's where these bounds come from. 0 to pi over 2 and 0 to pi over 2 for both of them. So the other thing that I need to do is convert this f of x, y, z over to spherical coordinates. So fortunately, we've got all these conversions right here, right? We know that y is r sine theta, and remember r is rho sine phi. I'm not going to go over that. You should be okay with that. But sorry, I got interrupted again, but I think I was saying r is rho sine phi. So if I take this r and replace it with rho sine phi, I get y is rho sine phi sine theta. So the other thing to talk about before I get this line right here is the volume element when we're doing a integration in spherical coordinates. That is rho squared sine phi d rho d phi d theta. That also is something that you should have seen worked out in the last class example video, whatever we want to call it, that we just had. So I'm not going to go over that right now, but that pops in for the dv. So I'm doing the triple integral over that region of f dv, right? Where all these pieces are come in. So 0 to pi over 2, 0 to pi over 2 for both the d phi d theta, and then 0 to 1 for the d rho. Excuse me. And then I get this rho sine phi sine theta. That's my f right there, right? So come down here. Um, this row gets multiplied by that row, gives me a rho cubed. This sine phi gets multiplied by that sine phi and gives me a sine squared phi. And then I get a sine theta and d rho, d phi, d theta. So this is fully separable. What I mean by that is the rhos, the phis, the thetas, there's nothing that can't be separated. So we sort of been doing this a little bit when we were doing cylindrical coordinates with the thetas, but um, we can separate all these integrals out, right? This is the same as the integral from 0 to 1 of rho cubed. Why is that? Because theta doesn't change at all for any of this stuff, right? So I could do this, right? So I get integral from 0 to 1 over rho cubed d rho times the integral from 0 to pi over 2 of sine theta d theta. Not sure why I did them in that order. and then integral from 0 to pi over 2 of sine squared phi d phi. Oh, the reason why I did that is because I knew that I could do these two integrals like moderately quickly, and that this one was going to take the most work. So this is just some power rule from 0 to 1, so I get 1/4 the coefficient for the power rule. Should be okay with that step. So also okay if you want to show that all the way out, that's no problem. Sine theta integrates to minus cosine. I evaluate it from 0 to pi over 2. So I'll just do that right here. Uh, Cosine of pi over 2 unit circle is 0. Cosine of 0 is, sorry, the negative cosine of 0 is -1, and then it gets subtracted. So that's going to turn into a positive 1. Then this part right here, I got to use some double angle formula work or power reduction, however you want to think about it. Either one's acceptable. But double angle that thing, I get the half from the formula, 1 minus cosine 2 theta, which gives me this theta, which gives me this right here. Then I need to integrate that guy. It gives me a half times this integrates to theta. This integrates to minus a half sine 2 theta, some chain roll in there. And then that evaluates from 0 to pi over 2. The sine piece gets zeroed out at both these spots. Sine of pi over 2, sine of 2 times pi over 2 gives me sine of pi, which is 0. Same thing with the sine of 0. And then the only other part is this guy, the theta, right? Well, that is going to get evaluated to this minus 0, right? So this whole integral right here gives me pi over 2. This half is that half. So I get this mess right here, which simplifies to pi over 16. So hopefully you feel pretty good with this. It's different to get used to, but once you sort of get used to it, you should be comfortable with doing them, especially when if you have this written down, right? And if we got constants, we should be good to go, right? We'll bump some up a little bit. But anyway, next one will be its own video. So I will see you in a moment.